An F1 car looks like one machine, but it's really thousands of parts built with extreme precision. Before it ever reaches the track, it begins as an idea on a screen, gets shaped by airflow in simulations and wind tunnels, and is then turned into carbon fiber parts strong enough to survive huge crashes. Every wing, suspension arm, brake duct, and body panel is designed to save time measured in thousandths of a second. This is how a Formula One car is made, step by step. The process starts long before any physical part is built. Engineers first create concepts in CAD software, shaping everything around aerodynamics, packaging, cooling, weight, and FIA rules. But they do not guess. F1 teams use computational fluid dynamics, or CFD, to simulate how air moves around the car. If a design shows promise digitally, it can move on to the next stage. This matters because airflow controls grip, drag, cooling, and overall lap time. In Formula One, even tiny changes in air behavior can transform a car's performance. Once computer data looks strong, teams validate it in the wind tunnel. Mercedes explains that successful CFD concepts are added to a scale model and tested physically, while Formula One has shown how teams and the FIA use these tunnels to compare the simulated airflow with the real thing. In the tunnel, engineers study how the front wing, floor, side pods, diffuser, and rear wing affect the wake behind the car. If the air does not behave the way they expected, the design goes back for revision. This loop of design, test, revise, and retest is one of the foundations of modern F1 development. After the design is approved, manufacturing begins, and the heart of an F1 car is carbon fiber. The most important structure is the monocoque, also called the survival cell, which protects the driver. Mercedes describes carbon fiber parts moving from raw material preparation toward autoclave curing, while official F1 safety coverage explains that modern survival structures use advanced composite materials to combine lightweight, stiffness, and crash protection. This is why F1 cars can be both incredibly fast and remarkably safe. Carbon fiber allows teams to build parts that are strong enough to handle huge forces while staying as light as possible. The carbon fiber process is highly manual. Sheets of pre-impregnated composite material are cut into precise shapes and layered into molds by hand. The direction of each layer matters because different sections of the car need strength in different directions. Areas around the cockpit and crash structures must absorb energy and resist penetration, while aero parts need to be light, stiff, and exact in shape. This stage takes patience and consistency because even a small flaw can ruin a part or compromise performance. Once the carbon layers are in place, the part is sealed and moved into an autoclave, a giant pressurized oven. Mercedes specifically highlights autoclave curing as a key part of the carbon fiber journey. Inside, heat and pressure harden the resin and fuse the structure into a rigid, lightweight component. This is where soft layered material becomes a real racing part. When it comes out, it still is not finished, but now it has the strength and shape needed for the next steps. After curing, the part is trimmed, machined, and inspected. Mercedes describes cured components being machined into final shape, tested, assembled if needed, and sent to inspection for final sign-off. At this stage, mounting points are finished, edges are cut cleanly, and tolerances are checked with extraordinary accuracy. Non-destructive testing helps detect flaws that may not be visible from the outside. F1 teams cannot afford a weak part, especially when the car will experience extreme vibration, downforce, braking loads, and curb strikes at high speed. With the main structure complete, the monocoque becomes the center of the car. The seat, steering system, pedal box, wiring, electronics, and safety hardware all have to fit inside or around this survival cell. FIA regulations require strict impact tests for the chassis and halo area, while Formula One has explained that the survival cell and roll structure face increasingly demanding safety standards. The result is a cockpit built not just for speed, but to protect the driver in one of the most dangerous environments in sport. Now the car starts to look real. Mechanics and engineers attach the front and rear suspension, steering components, brake systems, and gearbox. Each of these parts has to be incredibly light yet able to handle violent loads. Suspension geometry affects tire contact, cornering balance, and how the driver feels the car. The gearbox and rear end also help package the power unit and rear suspension, making this one of the most complex parts of the entire build. At this point, the car is no longer just a shell. It is becoming a complete machine. The power unit is then integrated into the chassis. Modern F1 power units are far more than engines. They combine the internal combustion engine with hybrid systems, energy recovery, electronics, and tightly packaged cooling hardware. Everything must fit inside a body shape designed for aerodynamic efficiency. That means radiators, intercooling solutions, plumbing, wiring, and exhaust routing all have to work together without hurting airflow too much. In Formula One, packaging is performance. A few millimeters can change both cooling and speed. After that comes the visible identity of the car: the nose, front wing, floor, engine cover, side pods, beam wing, and rear wing. These parts are not just bodywork, they are airflow tools sculpted to control how air reaches every other part of the car. Red Bull's factory material describes the process as the evolution of a car from concept to final assembly, where thousands of components are brought together in race bays. By this stage, the car is assembled with the precision of a spacecraft and the urgency of a race team. Before the car races, it must be tested and checked relentlessly. Some parts face development testing, some face non-destructive inspection, and the chassis itself must meet FIA crash test standards before it can run. This is where engineering ambition meets proof. If a part is fast but fragile, it fails. If it is safe but too heavy, it may still hurt performance. Formula One is all about balance: strength, weight, cooling, aerodynamics, safety, and reliability all have to work together at once. So that is how a Formula One car is made. Designed in software, tested in CFD and wind tunnels, built from carbon fiber by hand, cured in autoclaves, machined, inspected, assembled, and tested again before it ever sees the track. What looks like a single race car is actually the result of thousands of decisions and an enormous amount of precision manufacturing. Every lap begins here in the factory, where speed is built one part at a time.